Hello 171 class, this is your notes on section 1.7. In this section we're going to combine functions together. When we say combining them, we mean like add, subtract, multiply, divide them. And then we're going to compose functions. And what that means is we're going to put one function inside of another function. Alright, so the first thing we're going to do here is find a function's domain. And remember, a domain is a set of the inputs, the x values, that produce a real number when we plug it into the function. So we exclude numbers in the domain that would cause division by 0. Okay, remember you can't divide by 0. And real numbers that result in an even root, such as a square root of a negative. Okay, so you can't have an even root of a negative number. Okay, so division by 0, even roots of negative numbers, those are the things we restrict now. Later in chapter 3 we'll pick up some more, but for right now that's what we have to worry about. Even roots of negatives in division by 0. Alright, now when I'm looking at this and it's asking me to find the domain of this function, I have to ask myself, is it possible to divide by 0, and is it possible to take the square root of a negative? Alright, so we ask ourselves that with this first function. Is it possible to divide by 0? Is there division with x in the denominator? Well, there's no division, so no, it's not possible to divide by 0. There's no division, you can't divide by 0. Is it possible to take an even root of a negative? No, there's no square root symbol. There's no root symbol at all, so I don't have to worry about dividing by. I mean, not taking the square root of a negative, meaning like a symbol like that, the square root symbol. So since that's not possible, since we don't have even root possible, and we don't have division at all possible, we don't have any restrictions, right, that we've discussed so far. So the domain for this thing is negative infinity to infinity. There are no restrictions. Alright, now moving over to the other one. Is it possible to divide by 0? Is there division with x in the denominator? Yes, this is the division symbol. Fraction, remember, represents division. So we could divide, and if this down here, because there's an x in the denominator, if this down here is 0, if it produces a 0, if there's an x that makes the bottom 0, then yes, it is possible. Alright, is it possible to take an even root of a negative? No, so we don't have to worry about that, but we do have to worry about the bottom being 0. So how do we find the domain? Well, we set the bottom equal to 0, since that is a possibility, and we solve. So this is factorable, meaning I can write those two sets of parentheses that factor to this thing. I need two numbers that multiply to negative 3 and add to negative 2. So that's negative 3 and 1. And now each of these could produce a 0 and make this equal to 0. So if x minus 3 is causing this thing to be 0, remember we're multiplying, so if x minus 3 is 0, 0 times this is equal to 0. So if x is 3, x minus 3 is 0. So this says x could be 3. This says if x is negative 1, negative 1 plus 1 is 0, and 0 times anything is 0. So if this is 0, x is negative 1. Alright, now these are the two things that x can't be. So x can't be 3, and x can't be negative 1. Alright, and then the way we write that as a domain in interval notation is we say, we start from negative infinity, comma, we go up to the first thing that shows up left to right. So negative 1 is smaller than 3, so we start with negative 1. And then union, go from negative 1 to the other one, 3. Alright, and then union, go from the bigger one, 3, to infinity. There's more than one restriction. So this is our domain here. But to come up with that, we need to ask these questions to ourselves to know how we're going to come up with the domain. Alright, now we have, in these next two examples, we have some square root symbols. So we do have that possibility of an even root of a negative. Okay, so for C here, h of x equals the square root, is it possible to divide by 0? There's no division, so it's not possible to divide by 0. Is it possible to take the even root of a negative? Yes, now it is. Alright, now, because you cannot take the square root of a negative, there is no such thing in the real numbers as the square root of any negative number, because you can't square a number and get a negative number. So what we do is we don't want anything negative underneath the square root symbol. So that means that this stuff underneath the square root symbol, 3x plus 12, this thing right here can't be negative. Well, how do we write that mathematically? We say it has to be greater than or equal to 0. Right? The greater than are the positives, and then obviously 0 is equal to 0. Right? Less than that, if we switch that to a less than symbol, this is less than 0, that means it's negative. That's what we don't want. So we take away the possibility of less than, and that leaves greater than or equal to. Alright, now we just solve. Subtract 12 from both sides. 3x is greater than or equal to negative 12. Divide both sides by 3. I get x is greater than or equal to negative 4. So there's my domain. The x values that go into this thing have to be negative 4 or bigger. And the way we write that is an interval is bracket because of the or equal to. Negative 4, and then everything bigger than that goes to infinity. So there's our domain in interval notation. Okay, if we wrote it as a set, we would just write the set of all x such that x is greater than or equal to negative 4. You literally, once you've solved it, you can just put an x such that in front of it and then put the set brackets around it. But this is typically how it's going to be asked in your homework to give that domain. Alright, what about this one? Let's look at our two questions again here. Is it possible to divide by 0? Is there division with x in the denominator? Yes. Is it possible to take an even root of a negative? Because that square root's present too. Yes, there is. Alright, now, when the answer is yes to both of these, always start with the even root, because there's more things that are going to be restricted here than there are here. Okay, so typically we would say with the even root, if this was the only thing in the problem like we had last time, we take what's underneath the square root symbol and we set it greater than or equal to 0. Okay, but if this is equal to 0, we get the square root of 0, which is 0, and that would cause us to divide by 0. Alright, so all we have to do here in this case is change this from greater than or equal to 0 to just strictly greater than 0, and then solve. Alright, subtract 14 from both sides. Negative 2x is greater than negative 14. Divide by negative 2. And remember, when you divide by a negative with order symbols, you got to flip this thing from greater than to less than. A negative divided by a negative is a positive 7. So now it's all the numbers less than 7 will be okay in this function. Okay, so to write that, everything less than 7, that goes all the way down to negative infinity, and then it comes up and stops at 7. Okay, but we don't include it, so we put a parentheses. It's not underlined, so we use a parentheses. Okay, set notation, we would just write x such that x is less than 7. We didn't talk about it on the last one, but we can do these in set notation as well. This one, we would just write all real numbers. Is that double back R is a set notation for that. Typically, though, again, you would use this. But in this case, if you were writing set notation, you'd write x such that, and then you'd write these two restrictions. X is not equal to 3, x is not equal to negative 1. And what you're saying is x is any real number as long as it's not either of these two. Okay, so that's how you would write it in set notation, but this is, again, typically how you're going to be asked to write it. Alright, now, this is the combination of functions, or what sometimes we refer to as the algebra of functions. So that just means we're going to add, subtract, multiply, and divide these things. when you see sum, difference, product, quotient, it means the same thing as it did before. Alright, so the domains of these, after you've added, subtracted, multiplied, and divided, the domains of these, which is notated like this, domain of f and domain of g, means it has to work in both. The domain of f and the domain of g are combined, and it has to be something that satisfies both. So the way this works is, if the domain of f has these numbers, I'll put yellow, and the domain of g, this would be like the df, and this would be like the dg. Let's say the domain of g was here to here. We'll do it in a blue color. What we mean by this notation right here is df, this means intersect, dg. It's like there's that line, there's that line, there's that one, and then there's that one. It's like, because this is yellow, this is blue, what we would end up with here, as far as the picture goes, we'd have yellow here to here, we'd have blue here to here, and then this little area that's green is the intersection. Okay, so that little piece right there, that is part of this, and it's part of this as well. That's what we mean by that notation. Okay, the things that work in f and the things that work in g are the things that are going to work when we add, subtract, multiply, and divide them. Okay, now this is the only one we have to worry about potentially picking up new restrictions. You can't lose old restrictions. Okay, the only time you can, the only time you will in this case pick up new restrictions is right here. Now, there are some times where it looks like you lose restrictions, but just know that you can't lose them. You can only get new ones because of the way these things are defined over here. All right, so let's practice some, and we'll get the hang of what this notation means. Alright, so here's a function f, here's a function g, and we want to find these and simplify them. So for a, f plus g means add these two functions together. So if I took 2x minus 1 and I added x squared plus x minus 2, the 2x and the x are common, so that would be a 3x. The minus 1 and the minus 2 are common, so that would be a minus 3. So we end up with x squared plus 3x minus 3. Right? That's f plus g. Alright, part B. Same thing, but now I'm subtracting f minus g. Now notice when I subtract, I'm going to put this second function, the one that follows the subtraction, which is g. I'm going to put that entire function in a parentheses because I'm subtracting all of it. And what that means is I'll have to distribute the minus sign through and change all the signs in here. So I end up with 2x minus 1, which is just plain old f like it was to begin with. But then I get a minus x squared, a minus x, and a plus 2. Alright, so I changed all the signs for g. Now when I combine my like terms, still the same type of like terms, I have a negative x squared. 2x minus x is just 1x. And the negative 1 plus 2 is positive 1. So there's f minus g. Alright, so there's the first two, and then we're going to multiply and divide them next. Now, domain for each. This is a polynomial. It's not restricted. Polynomial means you just have whole number powers, like x to the second, x to the first on x. So polynomials will never be restricted because there's no division, there's no square roots. So the domain here was all real numbers, the domain here is all real numbers, the domain here is all real numbers. So D for domain, negative infinity to infinity. All reals. Okay, and if you intersect all real numbers with all real numbers, you get all real numbers. So that's what this notation is saying. Everything's, if I highlight everything yellow, and then I highlight everything blue, everything's green. So there's all real numbers is our domain here and here. Okay, same idea here. I don't have any restrictions because again this is just a polynomial. Alright, same thing. I'm multiplying them and dividing them. So for C, 2x minus 1 times x squared plus x minus 2. Just got to remember how to multiply polynomials. Remember, you distribute the first thing through all the second, and then you distribute the second thing in the first parentheses through all the second. So 2x times x squared is 2x cubed. 2x times x is 2x squared. 2x times negative 2 is negative 4x. And now I've distributed the 2x through, now I distribute the negative 1 through. So negative x squared. Negative x times positive x is negative x. Negative 1 times negative 2 is positive 2. Alright, and then combine your like terms. 2x cubed doesn't have anything like it. 2x squared and minus x squared are like, so that gives me a 1x squared. Minus 4x and another minus x are like, so that's a minus 5x. And then there's nothing like the 2, so I just leave it. Okay, this is still a polynomial. It's just everything's whole number powers. There's no division. There's no square roots and negatives. So the domain is still all real numbers, so negative infinity to infinity. Now D. F of x is 2x minus 1 on the top. G is on the bottom, so that's x squared plus x on the bottom. Now, that denominator, this is f divided by g of x, so there's our function, but the domain, now because this does have division on the bottom, we have to set that denominator equal to 0 and solve. So x, two numbers that multiply to negative 2 and add to 1 are going to be positive 2 and negative 1. Okay, so if this is equal to 0, x is equal to negative 2. If this is equal to 0, x is equal to 1. So that means our domain starts at negative infinity, and it hits this one first, so negative 2, union negative 2 to 1, right, and then union 1 to infinity. It's always this format. If there's two restrictions, you start with the lowest, negative infinity to the lowest to the highest restriction, and then the highest to infinity. That'll always be your domain. So this is what I mean by you can't lose restrictions, but you can pick up restrictions. So we didn't have any restrictions in the original f and g, but especially here when we bring in division, when there were no division in either of these two original functions, a lot of time you will pick up restrictions. So now, no restrictions, two restrictions. Alright, let's try this. these two functions have square roots, so they do have restrictions. All I can say for their addition is add them together. So f plus g is equal to the square root of x minus 3 plus the square root of x plus 1. That's all I can write. I can't do anything other than just put a plus sign between these two things because you can't add underneath a radical. Okay, so there's the function. Now, what's the domain? Well, let's look at each one. X minus 3 has to be greater than or equal to 0 for us to get output here for f. So add 3 to both sides. That's saying x has to be greater than 3. Right? X plus 1, that has to be greater than or equal to 0. So subtract 1 from both sides. I get x is greater than or equal to negative 1. That has to be true. The numbers have to be bigger than negative 1 for this to not have a square root of a negative. The numbers have to be bigger than 3 for this to be a square root of negative. So what we do here, you can kind of think through it. You may already know just by looking at it. But we use the yellow and blue make green thing again. Here's negative 1. Here's 3. Okay, this one says x has to be bigger than negative 1. Right? This one says x has to be bigger than 3. Now when I combine them together, notice when I lift this up here and let the 3 and the negative 1 be on the same number line, notice that the 3, it just all changes to green. So everything bigger than 3 is the green area that satisfies both f and g. So the domain is from 3 to infinity. Alright, so from 3 all the way on to the end. Remember, the right hand side of this is like infinity. It keeps going forever and ever and ever. So from 3 to infinity is our domain. Okay, or again, if you want to write it in set notation, set of all x such that x is greater than or equal to 3. Same thing as this. Okay, again, this is typically how you're going to be asked to write these things. Alright, but that's what I meant by the this notation. It has to satisfy both. And the only thing that satisfies both here is this region. Okay, this is saying numbers have to be bigger than 3. And this is saying numbers have to be bigger than negative 1. Well, any number that's bigger than 3 is also bigger than negative 1. But not all numbers that are bigger than negative 1, like 0, 1, 2, are bigger than 3. So we can't use all of this, but we can use all of this. So it ends up being the one that's further along in the direction that we're headed. Alright, what about these two? We're going to subtract and divide. So the domain here of f is negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. If I square 3, I get 9 minus 9 is 0. If I square negative 3 squared is also 9 minus 9 is 0. So negative 3 and 3 are restricted. So again, that's what it's got that look. And this is the same thing, obviously, because it's the same denominator. So this is the domain for f and g. So the domain for f minus g and f divided by g will at least be these. Will at least be this. But again, we may pick up another restriction. We can't lose restrictions. We can only pick them up. So let's do f minus g. So that's going to be f is first, so 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. Now remember, common denominator, that means I can combine the numerators over that common denominator. So x squared minus 9 on the bottom, 5x plus 1 minus 4x minus 2. So that gives me a 5x plus 1 minus 4x distributing that negative through, plus 2. Alright, over x squared minus 9. Now, 5x minus 4x is x. 1 plus 2 is 3. And then I'm going to go ahead and factor this. You'll probably see what's going to happen here. So that reduces all the way down to 1 over x minus 3. Now, this is what is important for you to understand what I mean by you can't lose restrictions. If I'm just looking at this and I'm asking the questions that I asked at the beginning, what's the domain? One of the questions we ask is there division? And can we divide by 0? Yes, we divide by 0 when x is positive 3. But when x is negative 3, like before, negative 3 squared is 9, minus 9 is 0. Negative 3 causes division by 0. Negative 3 doesn't cause division by 0 anymore. 1 over negative 3 minus 3 is negative 6. That's not 0 on the bottom. But the domain of this is still the exact same thing that it was, because you can't lose restrictions. Negative 3 was restricted in the original f and g, so it's still restricted even though it doesn't cause division by 0 anymore. Okay, so it's still there. It's still a restriction. So make sure that you understand that. Even though it doesn't cause division by 0 in the simplified form of this thing, it still is a restriction in the domain. Okay, you don't lose restrictions. Alright, now let's multiply them together. Or sorry, divide them. Remember, if I want to divide f divided by g, remember what we're going to do is flip this second fraction and multiply. So f divided by g ends up being 5x plus 1 over x squared minus 9 times, flip this around, x squared minus 9 goes to the top, 4x minus 2 goes to the bottom. These cancel. Now I have 5x plus 1 over 4x minus 2. Alright, now look. 3, positive 3, 4 times 3 is 12, minus 2 is 10. 3 works. Negative 3, 4 times negative 3 is negative 12. Negative 12 minus 2 is negative 14. Negative 3 works. So what's the domain here? Well, if you look here, what makes this equal to 0? If I take 4x minus 2 and set that equal to 0, I get 4x equals 2. So x equals 2 over 4. 2 divided by 4, or a half. That's the only thing that causes a division by 0 in the finished product. But once again, you got to remember, it doesn't matter. We're still going to start off from negative infinity to negative 3. We don't lose restrictions. Union negative 3 this time to 1/2, because that's a restriction now. Union 1/2 to 3. Alright, again, 3 is original restriction, so it's still a restriction. And then union 3 to infinity. Alright, so now we have 3 restrictions. Negative 3, positive 3, and now 1/2 that we picked up here at the end because the new denominator. Okay, so that 1/2 is new, but the original ones are still there. Negative 3, the positive 3 is still there. It's just now we have this 1/2 that's added to it. Right, you don't lose restrictions. So negative 3, positive 3 are still there, but you can pick up new restrictions as you combine functions together. Okay, that's what I mean by that. You don't lose them, but you can combine and pick up new ones.